So this just summarizes what section 9.2 entails. Thank you. Welcome to section 9.2, estimating the population mean. And at this point, we begin to work through the practice problems for this section. So we start with problem 1. Now, question 1. Find the t-value such that the area in the A right tail is 0.1 with 26 degrees of freedom. So before we start estimating our interval or doing point estimation, we want to know how to come up with our critical value, okay, or how to come up with a t-value when you are given an area in any of the tails and then a degree of freedom. So for the first question, it has given us the information of area in the right tail, which is 0.1, and then a degree of freedom of 26. So for the start, I'm going to use the table, the t distribution table, to show you how to get your t-value. So when you look at the table, the first column has the degrees of freedom. So in this question, our degree of freedom is 26. So we see 26 that has been indicated in the color blue. And then the area in the right tail. So remember, the table gives you areas in the right tail. So the areas in the right tail, now when you look at the top of the table, you see some numbers, right? So 0.25, 0.20, 0.15 up to 0.0005. Now those values are the areas in the right tail. So when we look at 0.1, which is the area in the right tail for this very question, then we look along the column for 0.1 and also along the row for degree of freedom 26, and then we get to the point of 1.315. So this value, which is shaded in blue, gives us the t-value, which has the area to its right tail being 0.1 and a degree of freedom of 26. So that is the answer for A. A is 1.315. Then B also says find the t-value which has the area in the right tail to be 0.025 with a degree of freedom of 18. So we look in the first column for degree of freedom of 18, and then match that with looking along the column for the area in the right tail of 0.025, and that value gives us 2.101. So the t-value for B is 2.101. All right. Now we come to C. So C says the t-value said that the area in the left of the t-value is 0.02 with 11 degrees of freedom. Now this is it. Okay, our table only gives us area to the right, but then our question has given us information on area to the left. So how do we go about this? Now, remember the t distribution is similar to the standard normal distribution. So that means the t distribution is symmetric. Okay, so and then the t distribution is symmetric or centered around 0. So it means that values to the right of 0 are positive, values to the left are negative. Now, if we are given an area to the left, right, of a t-value, but then our table has given us information when we have area to the right, we can use the rule of symmetry over here and find the t-value as though the area we are given is for the right. Then when we find when we find the t-value that corresponds to that area, then we negate that t-value. Okay, so what do I mean? So let's ignore the left information for now. So let's assume that we are looking for a t-value which has the area to each right to be 0.02. So looking in the table, and then with a degree of freedom, looking in the table, degree of freedom 11, area to the right of 0.02, we arrive at the t-value 2.328. Okay, so this becomes our result. But then we go back to the information which we ignored earlier, that the area we are giving 0.02 is actually to the left. So using the rule of symmetry, we just negate this value. So our t-value actually becomes negative 2.325. So the answer for C is negative 2.328 rather. Yeah, negative 2.328. Now, that is how you use the table to work around it. But in this class, you are allowed to use a calculator. Okay? So using the calculator step, which is actually really straightforward, we want to redo the three questions. So for A, we are given area to the right to be 0.1, and then the degree of freedom of 26. So the calculator function we use is the inf t. Now, you can find this function. Okay, this calculator function. I have given information on that in the PowerPoint, but then it's on the page 42 in the PowerPoint. Okay, page 42. But to get a t-distribution, just quickly going over it. Okay, in this very question, we use the inf t function. So you go to the same spot that you went for a normal distribution of binomial. So what you do is you go to second dist r, or second distribution, and then we look for the option 4, which is inf t, option 4. Now the first, this function takes two inputs. It takes the area to the left and then the degree of freedom. So remember, it takes area to the left and then the degree of freedom. So if we have area to the right to be 0.1, then the area to the left will be 0.9. Degree of freedom 26. So to 3 decimal places, our calculator results is 1.315. That is for A. So similarly, B, we have area to the right being 0.025 and a degree of freedom of 18. So inf t function, it takes area to the left. So area to the left will be 0.975, degree of freedom of 18, and our result becomes 2.101. Then the third one, we are given area to the left, okay, of 0.02, degree of freedom of 11. So inf t, now because we are already given area to the left, the first input will be 0.02, degree of freedom of 11, then the outcome is negative 2.328. Negative 2.328. All right. So that is how you go about finding a t-value or a critical value, which we'll see later on. So to question 2, which asks us to find the critical value t, the critical t-value that corresponds to 70% confidence. Assume 25 degrees of freedom. Okay. So we are not given so much information here. We are not told the area to the left. Okay. We are just told the percentage of confidence or the level of confidence, and then the degree of freedom. So how do we go about it? Now, from section 9.1, we know that there is a relationship between alpha and then the level of confidence. And that is 1 minus alpha equals the level of confidence. In this case, 0.7. So 70%, 0.7. So solving for alpha becomes 0.3. Okay. And our critical value, how do we find that? Critical value is T alpha over 2, taking into consideration the degree of freedom. And alpha over 2 being 0.3 over 2, that gives us 0.15. So we look for T subscript 0.15 with a degree of freedom of 25. What does this mean? It means that we are looking for a T value which has area to its right being 0.15. Okay, so if we simply use the calculator function, the inf t, what that means is the first input being the area to the left. Now, if the area to the right is 0.15, then area to the left will be 0.85. So 0.85 as the first argument, then 25 as the second argument, and everything resolved to give us a 1.058 to 3 decimal places, 1.058. So the critical value, the critical t value that corresponds to 70% confidence at 25 degrees of freedom is actually 1.058. All right. Then to question 3. It says determine the point estimate of the population mean and the margin of error for each confidence interval. So in this question, we are given the bounds, the lower bound and the upper bound, and we need to find the point estimate, okay, and then the margin of error. So how do we go about that? Now remember, the confidence interval for mu is given as the point estimate plus or minus the margin of error. And when we sketch for A says lower bound of 21, upper bound of 29. When we sketch, we realize that the x bar, which is the point estimate, lies exactly in the middle. Okay, so how do we find that? How do we find the middle value? That will be the sum of 21 and 29 divided by 2. So our x bar actually is 25. Our sample mean is 25. All right. So with that said, we want to find our margin of error. So margin of error is actually the distance from the mean to any of the bounds. So either from the mean to the upper bound or the mean to the lower bound. So to do that, let's consider from the mean to the upper bound. That will be 29 minus 25. That gives us 4. Alternatively to 25 minus 21, that gives us 4. So the margin of error for A is 4. Now to B, we have the lower bound of 5, upper bound of 23. So with that, the point estimate will be 5 plus 23 divided by 2. That gives us 14. Then the margin of error will be the upper bound minus the mean. Okay, and that gives us 9. Or if you do the mean minus the upper bound, minus the lower bound, that will also give you 9. 14 minus 5, that also gives you 9. All right. So now to a more complete question. Okay, that takes us through the process of finding the confidence interval. So it says a poll was conducted that asked 1,017 people how many books they had read in the past year. So a poll was conducted. Now results indicated that a mean of 11.1 books. Okay, so after taking that sample, the mean number of books that were read is 11.1 books, and then the standard deviation is 16.6 books. Construct a 99% confidence interval for the mean number of books people read. So the mean number of books people read is our population mean. So we want to make a confidence interval for our population mean. So recalling the formula, that is x bar plus or minus t alpha over 2 s divided by square root of n. So when we look through, we have some of our inputs already. We have our mean, we have our standard deviation, and also our sample size. Now, we need to be able to find the critical value t alpha over 2. But then what is alpha? We can know alpha from the confidence level. Okay, so the confidence level in this case is 0.99 because of the 99% confidence interval. So 1 minus alpha equals 0.99. So solving for alpha becomes 0.01. Then alpha over 2 is 0.005. Okay, So it means that we are looking for the critical value t sub 0.005 with a degree of freedom of n minus 1. But then what is n minus 1? That is 1017 minus 1, giving us 1016. So if we use the calculator function for finding the t value, that will be inf t, and then the first input is the area to the left. So always remember that area to the left. Now the information we have before now has been the area to the right, which is 0.005. So area to the left must be 0.995, and then the degree of freedom is 1016. Remember, degree of freedom is the sample size minus 1. So now our degree of freedom is 1016. Therefore, our result, our critical value is 2.581. 2.581. So when we put that back into the equation, right, into the expression, we realize that our confidence interval for mu is lower bound of 9.76 and an upper bound of 12.44. 9.76, 12.44. So this is how you get your confidence interval. But the beautiful thing is you don't have to go through the struggle. The calculator have a one-step approach for you that you can use to get your result. So from the TI-84, how do we get our confidence interval? Now, I have the direction here. You first, now if you are not using raw data, so in this example, we are not using raw data, so you skip the first step. Then you go to the second step. You press start, highlight tests, and select option 8, which is T interval. T interval. Now, if the data, so we don't have a raw data, right? So if you don't have a raw data, you don't select data, you select stats. Okay, what we have is a stat because we have the sample mean and then the sample standard deviation. So that is stats. Assuming we had the outcomes for a certain number of observations, then we would have done data. But we have start, so we just press start, highlight start, and then you begin to enter the summary statistics. So you enter your mean, you ask for your mean x bar, ask for the standard deviation s, and then the sample size n. Then you will also be asked for the C level. So C level is the same as the confidence level. In this case, the confidence level is 0.99. So 90%, you have to write it as 0.99. And then you press enter, and boom, you have your outcome, which is the confidence interval to 2 decimal places. That is 9.76 and then 12.44. So that gives us our confidence interval. You see, this is simpler than the first approach, but then it's always good to know how the calculator gives us the outcomes. Okay, so the next time you want to do this, just rely on your calculator. Now, one other thing we need to know is how to interpret our results. Okay, we've seen this in 9.1. So in this section, how do we interpret it? The rule is we are 99% confident that the population mean is between the lower bound 9.76 and the upper bound 12.44. So we are 99% confident that the population mean is between 9.76 and 12.44. All right. Then to question 5. It says a simple random sample of size n is drawn from a population that is normally distributed. Okay. The sample mean x bar is found to be 108, and then the standard deviation s is found to be 10. A asks to construct a 99% confidence interval for mu if the sample size n is 25. So now we just want to use the TI-84 function. So what do? We go through the process. So you press start, highlight tests, and select option 8, T interval. After that, because we have the summary start, you select stats, then you enter your sample mean x bar, s, and n. and also specifying the C level. C level in this case is 0.96. Then we calculate, and our outcome to one decimal place is 103.7 on the lower bound, and then 112.3 for the upper bound. So this gives us our confidence level with the constraint of 96% confidence interval, and then a sample size of 25. Now, B is a similar question, but this time around we have the same confidence interval, but then a sample size of 10. Okay, sample size of 10. So going through the same process, then our confidence interval becomes 100.4 and then 115.6. 100.4 and then 115.6. Now there's a follow-up question. It says, how does decreasing the sample size affect the margin of error E? Okay, so now let's look at this. When with a sample size of 25, okay, our interval is giving us 103.7 to 112.3. Now a sample size of 10, we have an interval of 100.4, 100.4, and then 115.6. So looking at the picture that I've drawn, you realize that the interval is wider when the sample size is smaller. Okay, and if the interval is wider, it means the margin of error is also larger, right? So the conclusion is that decreasing the sample size increases. Oh, I think there's an error here. Decreasing the sample size increases the margin of error. Decreasing the sample size increases the margin of error. Increases the margin of error. Okay, and this is because when we look at the graphically that shows right by demonstration, but when you look at it from an algebraic standpoint, you realize that the denominator of the margin of error is square root of n. Okay, now when n is a small value compared to n being a larger value, the outcome of this expression will be greater when n is small and will be smaller when n is large. So decreasing the sample size increases the margin of error. All right. Now some interpretations we can look at. So interpretation of a confidence interval. So in a survey, right? In a survey, 1,100 adults in a certain country were asked how many hours they worked in the previous week. Based on the results, 95% confidence intervals for mean number of hours worked was lower. So it was lower bound 38.3 and upper bound 44.5. So if we have these bounds, then how can we interpret our results? So to say that, okay, using the wording of the problem, we say that we are 95% confident that the mean number of hours worked by adults in this country in the previous week was between 38.3 hours and 44.5 hours. So this is actually a professional and a formal way of putting down your results, okay, or interpreting your confidence interval. But a faster way to go about it is just to say we are 95% confident that the population mean falls between 38.3 hours and 44.5 hours. But in this case, we are using the wording of the question. So we say we are 95% confident that the mean number of hours worked by adults in this country, because that is our population, okay, in the previous week was between 38.3 hours and 44.5 hours. Then 2 says a trade magazine routinely checks the drive-through service times of fast food restaurants. A 90% confidence interval that results from examining 734 customers in one fast food chain's drive-through has a lower bound of 169.4 seconds and an upper bound of 173 seconds. So an interpretation will be that one can be 90% confident that the mean drive-through service time of this fast food chain is between 169.4 seconds and 143 seconds. Alright, so that concludes it for this section 9.2. If you have any question, reach out to me and I'll gladly help you out.